Well, thank you, Joe, and the UK Flower Millers Association to give me the opportunity to present here today in this webinar. So, as Joe mentioned, my name is Denis Boisseau. I am the marketing manager of Beaumill, and I'm leading the marketing and communication activities for the company. But also, I am involved in on the commercial side for certain markets, including the UK. So today, I'm going to present how our technology can actually impact the grain industry and support the UK flour milling businesses to actually further optimize their wheat supply. But maybe first, let me briefly introduce our company, Beaumill. So we are a Swedish company. We're actually based in Malmö in the south of Sweden, very close to Copenhagen. And we develop and manufacture innovative grain sorting solutions, both for the agriculture and food industry. And our unique expertise is in single kernel sorting, based on the near-infrared in a transmittance mode. I will come back to this later in the presentation. Today we are present mostly in Europe and the Americas, either direct or through our regional distributors. So now we all know that climate actually affects quality and availability of wheat, and this is what the industry actually deals with every year at harvest. But the effect of the climate change, coupled with regulation, as Joe mentioned in the introduction, or geopolitical situation, price of energy, and so on, actually make this even more challenging for the future for the in the grain industry. And if we, as an example, if we look at the UK Group 1 category, which obviously you've seen those graphics before, in recent years we've seen the impact of poor weather conditions on the production and the quality of that category. And when you actually look at the AHDB quality survey over and actually look at national protein content, you can see that the trend is actually on the decline for the protein content. Looking at the 5-year moving average, we are declining every year now, and the actual average for 5 years for 2023 was actually below 13%, which is the requirement for, or at least the main specification on protein for the UK Group 1 category. And the protein premium, which you don't see on the slide, but protein premium, the price, the additional premium on protein is also an illustration of that tension on the market for higher quality. So this is something that obviously you all know very well, but the challenge for the flour milling industry is really to produce consistent flour quality, continue improving milling efficiency, despite this volatility in quality and availability of wheat. So adapting the milling recipes, importing wheat from other countries, and blending are some of the strategies that you already use. But the question is, what if there was an untapped potential in the wheat that's actually available today? What if there was another way to optimize the wheat procurement and use differently the wheat produced in the UK today? And that's what we're going to discuss also today. So we know that elements such as the microclimate, available water, soil, topography, etc., play a role in how crops actually grow. So it is common knowledge that there are quality variations between fields and even within a single field. But what actually is less known is there is actually also a significant variation between kernel when you look at a single spike. Each kernel has different characteristics, even if actually they are twins. And there is indeed a large protein variation between kernel of the same spike. Like I show in the example on the slide, it might actually vary from 9.5% to 12.5%. And this is actually often unknown, or at least not taken into account from a business perspective. So now, when we look at how the industry deal with the grain quality, because there is no way to check the quality of individual kernels, or at least not at an industrial level, average sampling is the norm. It's the standard that everyone uses. Maybe 2 or 3 samples are taken from a load, and the average defines the quality of that batch. But if we connect to what I presented in the previous slide, what is classified as a batch of 11% protein content may in reality be constituted of kernels ranging from 9.5 to 12.5. That's just an example, but and that does not even take into account the history of that batch, if there's been some blending or anything before that. So when you get that batch today, if you target a higher quality than this, either you source it from either you source it from somewhere else, or you blend it with a batch of higher quality to reach the required spec. And that actually increases further the variation, which might bring even more heterogeneity, and that may also further affect the performance of the subsequent processes that you might have afterwards. But when you look at the reality, so the right side of that slide, the desired quality may already be here in the batch. And it's just that you don't have a way to retrieve it. So this variation is always there, no matter the size of the sample or the load. We always see it. It might range from, there might be a range of, let's say, 2 or 3% protein spread, but it's always there. And this is actually an untapped, today, this is an untapped opportunity. So how do we take advantage of it? If we look at grain cleaning and sorting equipments that are actually used today, since industrialization over 100 years, the grain industry has been using various equipment for cleaning grains, which are still quite similar today. The most significant innovation that has been introduced lately is color sorter, evolving to become a standard in many industries. The similarities between all these traditional technologies is that actually the focus is on determining quality on size, density, shape, or color differences. And their main objective is to remove small portion of impurities. But neither of these technologies can actually analyze what's inside each kernel of a batch. So bow mill brings a new dimension to sorting, with actually a unique way to sort each kernel of a batch based on their inner properties. So the sorting of our technology consists of 3 steps, as you can see on the slide. So one step, the first step is what we call the singulation, which actually ensure that each individual kernel are actually separated from each other. Then we have the second step, which is the detection, where data on each individual kernel is actually gathered. So here what we do is, or the technology does, is that we shine near-infrared light through the kernels. So it's not, what we're looking at is not the reflected light, like you would have, for example, for an optical sorter. What we are looking here is the transmittance. So it's actually the signal that is received on the other side of the kernel, which actually gives information to predict quality, such as protein content or damage by fusarium, for example. And the third step of our technology is the ejection. And here, each individual kernel is precisely ejected when needed, depending obviously on the setup, and that's using compressed air to do that. And for those who are actually familiar with the color sorter, one of the key also elements of our technology that is different from a color sorter is that we have a full control of each individual kernel all the way through our equipment. So both detector and ejector are actually integrated in the chute. And so this actually gives higher precision of ejection and measurements of data. If we come now back to the earlier example, our technology actually assess the quality variation in the batch. So as you can see in the slide. So basically, the technology is actually picking up the data that I mentioned in that second step and gradually build the bell curve, which is based on the qualities of the different kernel and their occurrence in that batch. And this actually reveals the actual variation in the batch. Now, how you actually use it? So you can actually decide where to put the threshold to produce two fractions. So you decide on the threshold. In this example, the threshold is positioned in the middle. So we actually split the batch in two fractions of equal size, which creates two new qualities. 10 fraction 1, 10.5% protein content, if we started with 11 as the raw material, and then fraction 2, 11.5%. So that's how the principle works for defining the target quality you need. You actually implement a threshold on how you want to split your batch. So 50-50 in that case. But you can also decide, or you actually might want to target high protein level. So in that case, you actually move the threshold towards the right-hand side on that slide. And then by this, you actually reduce the yield of the fraction 2 and actually increase the protein content in that fraction. So in this example, you can actually extract a fraction that within the 11%, a fraction that was actually at 12% protein content. In the same way, you can actually target low protein levels and move the threshold to the left. Or what you can do actually, what we have actually identified with our technology is we in a position where we did identified a secondary correlation with the fusarium infestation, or how the grain are damaged by the fungi. So it's actually a way for those that actually, when you have a batch that is actually very high with a done level very high, then you can remove a very small portion of the most highly infected kernels to actually go down, reduce the level of done of the overall batch. So that's a way, in a way, to upgrade or save a batch that is out of specification because of the done level to actually save as much as you can from that batch. And finally, another kind of way to use the technology is in the case where you really want to produce a higher homogeneity, you can actually set up two thresholds. This way, the fraction 1, which is the middle fraction, contains kernel of a really more uniform quality, making the fraction of higher quality in a sense because it's got better and that may have better predictability for the milling process, for example, or at least tampering and so on. So our technology actually has two outlets. So when you separate a batch, it's two fractions that you're producing. So in that particular case, the outer parts of the graph would be combined in the fraction 2. So that would obviously be quite an heterogeneous batch. But an interesting fact there is that if you are testing both fraction 1 and 2 in the lab, you would actually get the same results on the protein content, while they are very, very different. So that's also an illustration here of how blending and variation, how you can actually see variation, even if in that case you would not see it in the lab, but it could be very different in the batch. So based on what I presented, we can now exploit the variation of protein in the batch. Wheat that is actually today too low in protein can actually be upgraded, and I'm not talking about blending. Here I'm talking about the sorting, and now a batch that is out of spec on protein can actually be upgrading, and we can extract on high side, but also in some case on the low side, some good qualities from that batch. A very simple information about so the technology. The technology I introduced earlier, we actually implemented it in our most recent equipment that we actually launched last year. It is called Bowmill Insight and was developed to actually I would say revolutionized in a way the grain sorting through high-speed single kernel sorting, and that's really linked to the new dimension of sorting that I was referring to earlier. So Bowmill Insight actually allows an accurate sorting based on the inner quality of each individual kernel at industrial speed, from 2 metric tons up to 120 metric tons per hour. So it really meets industrial capacity requirements with the flexibility to actually increase the capacity as the needs actually also increase. It's easy to install and operate. We have a really attractive running cost, which makes the return on investment for our customers very fast. And the machine is actually designed to run for 24/7 production, and some of our customers currently use it that way. So I will now show you how this equipment can actually help exploit the untapped potential we discussed earlier and make process more efficient. So we're going to look at an example of a use case with one of our customers, so a European flour mill. In that case, the objective is to actually substitute premium quality with an upgraded standard wheat quality. But first, let's look at what the challenges the mill was actually or is still facing in a way, which probably we can see similarities also with the situation in the UK. So when the customer looked at our technology, the situation was there was, as we experience everywhere, grain quality being more volatile between harvests. That's something that we see commonly. But there was also a trend, or at least the customer sees that in the future there will be more and more pressure on fertilizer uptake through regulations, but also with the limitations, as we've seen in the past few years, on maybe cost of fertilizers increasing a lot. So this actually on fertilizer, they saw that there was a threat that the input might actually be lower and lower, which would have an effect on the protein content of the wheat they procure in the future. Also, very localized declining availability of locally produced premium wheat for different reasons, maybe less produced, but also because there is more and more demand from other countries or other regions. So less availability, which leads to increasing cost for the premium quality wheat with a higher protein. So overall, there was a kind of, the idea here was to kind of anticipate as well the future, even if there is actually a case economically now. The idea is to have also the solution to prepare for the future, for now and for the future. And so before, this mill was purchasing a certain amount of standard wheat and premium wheat with as an example here, this might have changed since, but premium of around 30 euro for the latter, sort of for the higher premium quality. And the objective was really to purchase more of the standard wheat, upgrade it in order to actually lower the procurement of premium wheat. So using that upgraded standard wheat to substitute some of the premium wheat. So how this actually work? The standard B wheat is sorted with the bone meal inside to generate two fractions, an upgraded standard B wheat with a higher protein content, and the remaining fraction of B wheat, which obviously has a slightly lower protein content compared to the raw material. But that lower fraction is actually used directly or blended for less demanding markets, such as the retail flour. That's in that case, that is the way they're actually using that fraction with a slightly lower protein content. But it can be also in some case that the customer look for maybe other specific application where the even lower protein might actually be interested or be like a large volume required. So then that fraction can be used also. So after actually checking the baking performance of the well, let's go back. So they had initially kind of a wheat blend of a certain proportion of this standard wheat and certain of proportion of premium wheat, so 80-20. What they were looking at is what would be the baking performance of the if we were actually replacing the premium A wheat with the upgraded B wheat, and it looked like properties were quite similar, and that's so effectively in that case they actually replaced some of that A wheat by the upgraded B wheat, and this is actually an example. In some case, you might actually the substitution may not be like for like the same proportion, and recipes and proportion may be slightly altered. So it's very dependent on the flour you produce and so on. But overall, the primary benefit is the cost savings on the wheat cost per ton of flour that is actually generated by this substitution. That's for that case, that's really where the primary benefit is. If I come back briefly about where we actually are active. So today, the Bowmill Insight, we actually focus on wheat and barley. So we actually bring value to flour mills, grain elevators, or flour mills, malt houses, and obviously we also work with their suppliers, so grain merchants and cooperative. So just to briefly touch on example of installations. Uh, so since the launch last year, we actually installed a sorting solution in many different locations and countries. One of them is actually a grain terminal of the Swedish cooperative Lantmännen, where the objective is really to upgrade wheat and barley. And in that case, the Bowmill Insight was actually delivered as a mobile solution. So it's actually included also the supply of compressed air to actually bring more flexibility for the customer. But we also work with barley leaders such as Viking Malt and AB InBev using our technology to actually upgrade out of spec barley and target specific protein content for the brewing and distilling business. And already 3 flour mills have also identified the benefits of using our solution to optimize their wheat procurement by using either more domestic wheat, and as the example I showed earlier, upgrading standard quality. Now, going back to the situation in the UK, if we look at, we don't have yet the official report for 2024, but it doesn't look too good. But if we look at 2023 on the left-hand side of that slide, you can see that actually only 38% of the UK Group 1 is actually in conformity with the protein level requirements. And when you look at actually, there is actually 25% that's complying on the specs for falling number and specific weight, but not for protein. So there is actually potential to, in that example, 25% complies with both, but not the protein. So that's something we can tap into. And when you look at historic data over, let's say, 5 or 10 years, actually, the average is pretty similar. We are looking around 40%. That's actually comply on the specific weight and the falling number, but not protein. That is 40% that is actually not used for what it was grown for, or at least not in the most optimum way. So based, if you actually give an overview in terms of volume, I mean, if we base that on 3.7 million tons of yearly production for the UK Group 1, that's 1.4 million tons of wheat that we can tap into. And if I look maybe a bit, if I narrow that a bit, if we just look at between 12 and 13%, so the UK Group 1 that's in that range, that's still 20% of what is actually produced in the UK. So that's 700,000 tons. That is out of spec, at least for I mean, it doesn't mean it's not today. It's obviously used, but it's used for not exactly what it was initially grown for. So there is potential. And here I don't talk about the wheat material that is also way above the specifications, because I showed example earlier. You can actually, if you have a material that is at, let's say, 13.5% protein content, you can also extract the portion that with the highest protein content to still remain 13% for your core fraction, but still get maybe a fraction that is higher that you can use for maybe other specific applications. And also the same for the material that is actually imported today to the UK. There is also variation in that that material, and that can also be exploited, just as I illustrated in the use case earlier. So to conclude, I can actually make a short recap on the benefits that our technology can actually bring. So obviously, optimizing the sourcing is the main source of benefits, at least the most obvious. With a more efficient use of the raw material, saving on cost savings on the protein premium and import costs. But the technology can also bring further benefits on other areas, such as the process efficiency, for example. And that's mostly because we are bringing more homogeneity as well. So you can actually have a more consistent, if you actually bring the homogeneity, you can have maybe a more consistent and predictable wheat quality. You can optimize the conditioning with a more uniform quality. And that obviously has an effect on the improved, on the milling performance. So you can also in that way increase your milling yield. And also quality of the flour. Of course, with a more homogeneous quality of wheat, then you will get a more consistent flour quality for your customers, industrial customers, for example. And you could also target specific qualities for certain type of industrial customers too. So overall, with our technology, we actually can support flour millers to differentiate from competition, save on costs, so optimize also process. And I added to that, and Joe mentioned it, the sustainability profile. We can help to actually use more of what's available locally. We can actually have, when there are years where the protein is a problem, then we have a way to actually retrieve more than what's kind of like obviously available. So on the sustainability element, we also have we can also give some support to our customers. So that's it. Thank you very much for your attention. I understand we have the Q&A session now, but feel free to reach out to me if you have any further questions. Are you willing to actually explore in more details the potential for your business?